start our talk again on scientific math and sig figs and rounding by a quick review of rounding. Remember, there's really only two rules about rounding, and that is you find the place where you're going to round in a long number, and you look at the number behind it. If the number behind it is less than 4, then the number stays the same. If the number behind it is 5 or greater, then you round up. We ignore all these rules down here and only use the first two. Well, there is a gentleman named Tyler DeWitt. I'll talk about Tyler a lot this semester. He's one of my favorite online teachers, a graduate student. Now, I'm sure he has his doctorate, but these are one of his younger videos, and he says this: why are sig figs so important? Well, to make sure that answers you get aren't more precise than the numbers you started with. We're looking for the weakest link in every calculation. And there are a series of videos that Tyler shows on significant figures. And if you start with the link at the bottom of the slide and work your way through video after video, you'll become an expert on significant figures. So now that we know how to figure out significant figures, let's see, what do we do with them? What if we're having two numbers we need to add and subtract, and each of those numbers has a certain number of sig figs? Our answer has to have the same number of decimal places as the least accurate of the original numbers. So if we are adding 1.2 and 3.6578, when we add them together, our final answer can only have one decimal place. Same thing with subtraction. You line up the decimals and you see which number is the least precise, and that's how precise your answer should be, counting decimal places. Well, when we multiply and divide with sig figs, we're looking again for the weakest link, but this time we're just counting sig figs. We don't care about decimal places. We just say this number has, suppose, 3 sig figs, and another number, suppose, has 4 sig figs. If we multiply or divide those, our final answer can only have 3 significant figures. Let's look at some examples. Again, here's a video from that series with Tyler that would show you adding and subtracting of sig figs, dividing, multiplying of sig figs. And I put the links there at the bottom of the screen so that you can use them. All right, let's look at a sample problem. We're going to do these calculations, but it's very important that when we express our answer, the answer that we will box in and say this is the final answer, it has to show the correct number of sig figs. So here's one: 5.44 meters minus 2.6103 meters. Looking at this very quickly, we can count the number of decimal places. This one has 1, 2. This one is much more precise, has 1, 2, 3, 4. But when we subtract them, our final answer can only have 2 decimal places. Here, if we're multiplying, this number has 1, 2 significant figures, 2.4 grams per milliliter times 15.82 milliliters. And notice sometimes the units can be different when we're multiplying because we're using a formula. The different variables have different units. But the math portion of this is that this has 2 sig figs, this has 4, so our answer can only have 2 sig figs. Let's look at the solutions. Here we go. 2 decimal places, 4 decimal places. We subtract, and our calculator is still going to give us 4 decimal places, but we know that our answer can only have 2 decimal places, and this is how you would box in your answer if you were doing this on a paper test. 2 digits to the right of the decimal, and that's because of the input here that was less precise than this input. Okay, in this case, we multiply these together, and look, this one has 1 decimal place, this one has 2, but our answer has none. That's because when we're multiplying and dividing, we forget about decimal places and just look at the precision of the actual number. Whatever they measured with, they could only get precision to 2 sig figs here. So our answer can only have 2 sig figs. It wouldn't matter if you put a decimal behind this number because a decimal would still only show 2 sig figs, but you do not have to put that. And of course, again, showing you the 2 sig figs that drove the answer to have 2 sig figs. Well, a lot of times we use things called conversion factors, and we say that there's no uncertainty in a conversion factor. When you go to college, some of your professors may disagree with this, and you have to follow the rules of the class that you're in, but in general, we take the conversion factor as being true and not counting sig figs. So let's look. Most exact conversion factors are defined quantities. One that I want you to memorize, and you should write this down on a card or somewhere that you study, maybe an index card if you use vocabulary cards, is the quantity 1 inch equals 2.54 centimeters. 1 inch equals 2.54 centimeters. You will be required to know that by heart. Let's talk about scientific notation a bit. Scientific notation, as you can hear in the name, is used a lot in science. And it is written in this sort of formula-looking format where you have some number in the front that has to be greater than or equal to 1, but less than 10. In other words, the number in the front of the x, the multiplier, can only have a value of 1, 2, 3, 4, 5, 6, 7, 8, 9. And n here is the power we raise the 10 to represent that number. For example, if I measured this tiny amount of millimeters, 0.123, 3 zeros, then a 1 and a 2. We rewrite that by moving this decimal 1, 2, 3, 4 places and showing that we have to multiply it by 10 to the minus 4 to represent a tiny number. Tiny numbers always have a negative exponent. The units, millimeters, stay the same. We move the decimal point 4 places to the right and multiply it by 10 to the negative 4. Okay, let's look at another one. How do we determine that m? Well, we move it to the right or to the left so that there's only one digit to the left of that decimal point. And we determine n by counting how many places we moved to get to the decimal point. If you move towards the left to get to the decimal point, then you'll have a positive exponent. If you move to the right in a tiny number, then you'll have a negative exponent. When we do mathematical operations such as addition and subtraction, we have to get both numbers to have the same n, the same exponent, or we can't add them. For example, 4.2 times 10 raised to the 4th and 7.9 times 10 raised to the 3rd. They're both in kilograms, but these factors don't match. So we have to change one of them. So, for example, we can write both of them as 10 to the 4th. 4.2 was already 10 to the 4th, but 7.9, to make it be 10 to the 4th, for this number to go up higher here, this number has to shrink. So the decimal place moves once to the left. This number's to go up, this number has to go down by a factor of 10. So we would get this answer. But looking at our answers, remember we talked about decimal places. So here's one decimal place, both in the original number. So our final answer has to have one decimal place. Another way to do this that is used if we don't have a calculator available or you don't have a scientific calculator especially, is to just multiply the first part of the expression, the number in front of the x, together, and then add the exponents algebraically. You may remember that if you have powers of 10 and you're multiplying them together, you just add them. So this would be 6 plus a minus 2, a negative 2, which could give you 4. And then you could put this first number and this first number in your calculator and multiply them. Let's see how that comes out. This times this, and this times this. You would get this big number times 10 to the 4th. And when you multiply units or labels, then just like an X or a Y in an algebra problem, you raise it to a higher power. So here we have 37.133 times 10 to the 4 micrometers squared. Why did we chop it off? Do you remember? We look back here and we see that this input value only has 2 significant figures, and thus our answer can only have 2 significant figures. If you don't understand this example, stop the video, go back and watch it one more time because this is important. Okay, what if we're dividing? Well, then we subtract the exponents. You may remember that from using powers of 10. If you have 10 to the 7th divided by 10 to the 4th, then you can write it as 10 to the 7 minus 4. And you can take the front part of these two expressions, the 5.44 and 8.1, and just divide those in your calculator, and then multiply it by 10, and just do this simple subtraction. Sometimes putting these whole expressions into your calculator causes more problem than it's worth. So this is a shorthand method that I highly recommend. Use the first factors in the division, and then just adjust your exponents by a simple subtraction technique. This is called the law of exponents, these problems that we're working now. So here's the big calculator answer that it spit out. 1, 2, 3, 4, 5, 6, 10 decimal places times 10 cubed. Well, there's no way we can say that our answer had this much accuracy. So we go back to our original numbers and we look. This one has 2. This one has 3 sig figs. 2 sig figs here, one before, one after the decimal, 3 sig figs here. So which one is the worst precision? This one. So our final answer can only show 2 significant figures. And here is another of Tyler's videos. Again, if you go to that original one called Sig Figs Made Easy and go to the subsequent videos, he will answer a lot of these questions that you can see him work through problems that we maybe won't be able to have time to do on the board. But again, refer to his videos, and he is a great help. I think I'm going to stop there for now and talk about analyzing problems on the next video.